Hello students, we have been discussing regarding the heat change of a system with specific condition at a constant pressure, at constant volume. Already we have discussed when heat change takes place at constant pressure, that is called enthalpy, and heat change for a system at constant volume, that is called internal energy. But in terms of heat change at constant pressure or constant volume, for a particular substance, this heat content varies from substance to substance. The amount of heat absorbed or heat evolved for a particular substance depends upon the temperature and also depends upon nature of substance. Mainly two factors: amount of heat absorbed or amount of heat evolved from the substance. It depends upon the temperature and also depends upon nature of substance. So today we will discuss the heat change with respect to temperature at constant pressure and constant volume. How much heat change takes place, which is greater, which is smaller, and we will discuss this thing and we will derive the relation between these two factors. So what do we mean by heat capacity? Heat capacity, it indicates for a particular system how much heat is absorbed. Let it be how much heat is absorbed by the system per degree rise of temperature. That is called heat capacity. What is the meaning of heat capacity? The amount of heat absorbed by the system per degree rise of temperature. Clear? So what does it mean? The amount of heat absorbed by the system per degree rise of temperature. That means how much heat is absorbed by the system for increasing 1 degree, for raising the temperature 1 degree. How much heat absorbed? That is called heat capacity. And generally heat capacity expressed as C. It expressed as C. C is called heat capacity. But what is the meaning of molar heat capacity? What is the molar heat capacity? Molar heat capacity. Molar heat capacity is equal to Cl. Cl means molar here. Mole means per mole. So heat absorbed per mole per degree rise of temperature. If the amount of substance is fixed per mole, that is called molar heat capacity. That is called molar heat capacity, means amount of heat change takes place, amount of heat absorbed per mole of substance per degree rise of temperature. That is called molar heat capacity. And what is the specific heat? If you say specific heat, or it is called also specific heat capacity. Specific heat capacity. Specific heat capacity in terms of molar heat capacity, that means taking 1 mole, but if you take per gram, that means heat absorbed for gram of substance per degree rise of temperature. So it is fixed, mass is fixed per gram, and temperature how much change? Per degree temperature. That is called specific heat or specific heat capacity. Okay, let the Q amount of Q heat, Q joule of heat is observed to raise the temperature from T1 to T2, T1 Kelvin to T2 Kelvin. If temperature changes T1 to T2, then Q amount of heat is observed to raise the temperature. Okay? For m gram substance, for m gram, here mass is m gram, temperature T1 to T2, and heat is Q joule. So, what is your specific heat capacity? Specific capacity is C. Short form is CS, specific heat capacity. CS is equal to, here Q amount of heat is let be observed, and per degree, what is the definition? Per gram per degree. Here gram, m gram, per gram means by m. Temperature how much increase? T1 to T2 means T2 minus T1. So this is the derivation of what? Specific heat capacity. Amount of heat absorbed in joule or kilojoule per gram per degree rise of temperature. This is your implies, this indicates what? Q is equal to total heat absorbed is equal to specific heat of substance into mass into delta T. If you multiply, Q is equal to Cm delta T. This is the calculation of amount of heat absorbed but a particular substance, where different substance has different specific capacity. CS is not same. It varies from substance to substance. And CS into how much mass given and delta T, how much temperature. If delta T is more, then Q will be more. If mass will be more, then Q will be more. If CS will be more and Q will be more. It depends upon the what? CS, mass and delta T. So this is the different specific heat of a substance. But the specific heat capacity, it is as, or you can say molar heat capacity are two types. Types of specific heat. There are two types. One is called molar heat capacity. Molar heat capacity at constant volume. That is called CV. And molar heat capacity at constant pressure, that is Cp. There are two types of heat capacity, that is heat capacity at constant volume. Molar heat capacity means per mole, and molar heat capacity at constant pressure, that is Cv. So if you express this one, Cv is equal to, you can tell, change of heat at what? You can say as enthalpy change as constant volume, we can tell U, because constant volume means internal energy. So change in heat with respect to temperature at constant volume, that is called Cv. What is Cp? Cp is equal to change in heat means enthalpy with respect to temperature at constant T. So Cv is equal to del U by del T at constant volume, and Cp is equal to del H by del T at constant pressure. This is the difference between internal energy and enthalpy. Both Cp, Cv, these are unit is same, but the expression are different. Cv means with respect to internal energy, Cp means with respect to enthalpy, because constant pressure, constant volume. So this is called heat capacity at constant volume, heat capacity at constant pressure. But we know that one relation that we know that H is equal to U plus PV. Already we have read H is equal to U plus PV. And when for 1 mole of gas, we know PV is equal to energy. So H is equal to U plus RT. Here implies PV is equal to nRT. For 1 mole, PV is equal to RT. This is relation. So what happens? H is equal to U plus RT. If H is equal to U plus RT, if you this equation, if you derivative, in the form of derivative, it will be del H upon del T at constant P is equal to del U by del T at constant V plus, here R with respect to T, so it will be R. T will be cancelled. Here H with respect to T, derivative of H with respect to T at constant pressure. Here derivative of U with respect to T at constant volume. Here with respect to T will be R. So del H by del T, you know this is called Cp, and del U by del T, that is Cv plus R. So now we can write in another form that implies, this is implied Cp minus Cv is equal to R. What does it mean? Cp is, because R is a what? R in terms, R is a physical quantity, it has value greater than 1 in terms of joule. R value, that is 8.314 in terms of joule. So in terms of joule, Cp minus Cv is equal to R. In terms of Cp minus Cv is equal to 8.314, because R value is 8.314 for joule, for Kelvin, for mole, like this. That is joule for Kelvin per mole. This is the Cp minus Cv is equal to R. Cp is always greater than Cv. So this derivation indicates the relation between Cp and Cv, heat capacity at constant volume, heat capacity at constant pressure, the relation between Cp with respect to enthalpy change, and relation between Cv with respect to internal energy. Because V means constant volume means internal energy, constant pressure means enthalpy. So this is the one important derivation. Cp and Cv, both if you say, these are the amount of energy. The amount of energy possessed by the system depends upon these three types of motion. One is translational motion. Second one is that vibrational motion. Another is rotational motion. So these three types of motion is important in the calculation of energy, internal energy possessed by the system. But and also it depends upon types of molecule. Types of molecule means what? It depends upon monoatomic, diatomic, or triatomic, like this. If it is a monoatom molecules, then the value of which one? the value of the calculation of Cp, Cv also differ. For monoatomic, for diatomic and for triatomic, the calculation of Cp and Cv also different. But it has been observed that for monoatomic gas, Cv is equal to 3 by 2 RT. 3 by 2 R. You can say 3 by 2 RT. Okay, Cv is equal to 3 by 2 RT. Cv is equal to how much? 3 by 2 RT. If this one with respect to temperature means it will be, result will be 3 by 2 R. Result will be 3 by 2 R. And Cp is equal to 5 by 2 R. This is for monoatomic. For diatomic, Cv is equal to 5 by 2 R and Cp is equal to 7 by 2 R. Just 2 will be added. For triatomic, Cv is equal to 7 by 2 R and Cp is equal to 9 by 2 R. It will be like this. You have to remember the relation between Cp and Cv for monoatomic, diatomic, triatomic. Then the ratio of Cp upon Cv. As Cp is always greater than 1, Cp is greater than Cv. So Cp and Cv ratio, this is called gamma. This Cp and Cv ratio is gamma. When if you put this value, then Cp and Cv ratio, when it will be 1.5 by 2 or 3, if 1.66. If it will be 1.66, that is called as monoatomic. This is monoatomic. If it will be 1 point how much? 40. If it will be 1.40, this is diatomic. 1.30, that is triatomic. Just you see, when the diatomic means O2, N2 like this. Monoatomic means helium, neon like this. Diatomic means OH2, O2 like this. Triatomic means O3 like this. So these are the some different types of molecule and their Cp and Cv ratio. Cp and Cv ratio always greater than 1 and the gamma, this is called gamma. This is the derivation of Cp and Cv ratio. From Cp and Cv ratio, from gamma value, we can tell what is the nature of the molecule, whether monoatomic, diatomic or triatomic like this. So this is a very important expression of that Cp and Cv ratio. Then now we will discuss some problem. Okay? So the problem we will discuss the problem like this. Problem is, let 10 gram iron is heated to temperature 25 degrees Celsius to 500 degrees Celsius. That means, but you have taken iron 10 gram, when you supply heat, temperature change to 25 to 500 degrees Celsius. And the specific heat of iron is given, how much? 0.45 joule per degree per gram. Okay? This is the amount of what? Specificity of particular substance is fixed. For iron, the specificity is 0.45 per joule per Kelvin per gram. This is given. So what is the answer? Question is, so how much heat is required? So what is the value of Q? What is the value of Q? Already you know the formula that Q is equal to MC delta T. Here M is 10 gram into C is 0.00. C is how much? 0.45 joule. Okay, and T is here 25 to 500. How much difference? 25 to 500 units. How much? 475. That is 4. Here delta T will be 475. Difference will be 475. So 10 for that full formula. M is the mass of substance taken, C is the specific heat, delta is the difference. Maybe in Celsius scale, maybe in Kelvin scale. That is no problem. Only difference you write. Your difference is 500 minus 25. That is 475. So answer will be, you calculate now. What will the answer? Pause the video and write down and calculate how much result. So result will be 2137.5 joule. This much of heat is needed to raise the temperature of 10 gram of iron from 25 degrees Celsius to 500 Celsius. This much of heat is required. It depends on specific heat is 0.05. So this is regarding the calculation of amount of heat required. Then problem 2. Second problem is like this, that 5.6 decimeter cube of unknown gas at STP. 5.6 decimeter cube of unknown gas at STP requires how much heat? Requires 52.25 joule. Required 52.5 joule. 52.25 joule heat required with temperature difference. Required this one's heat to raise the temperature. How much? 10 degree. To raise the temperature 10 degree. Okay? 10 degrees Celsius. 5.6 decimeter cube of unknown gas. This is the volume. This is the volume of gas at STP. Required 52.25 joule to raise the temperature 10 degree Celsius. Given. Then but here at constant volume. At constant volume. Data given. At constant volume, this much of heat is required. Okay. Question is calculate CB, CP and gamma. We will calculate CV, CP and gamma. So again I am repeating this one. What is given? 5.6 decimeter cube of unknown gas at STP required 52.25 joule to raise the temperature at constant volume. You see the data. That much of heat at constant volume means what is given? If 52 joule given and at constant volume, what is given? What is that? Related to CV. And 52.25 J to raise the temperature 10 degree. But we know, just you see 5.6 decimeter unknown gas at STP. We know answer is like this. We know 22.4 liter, that is equivalent to 22.4 dm cube, both are same, is equal to 1 mole at STP. Already you know this mole concept. 22.4 liter, that is 22.4 decimeter cube equivalent to 1 mole at STP. So 5.6 bm cube will be equal to how many mole? It will be 22.4 by 5. That is how much? How many part? That is 4 part. That is 0.25 mole gas. So number of moles of gas given. As number of mole of gas given, then already know number of moles given and temperature is given. Then heat required is given. Then per mole will be how much? So CV, because at constant volume, CV is equal to Q is 52.25 joule upon per mole you have divided 0.25 mole into temperature is 10. Okay, well already you know CV is equal to Q by M into delta T. So this formula, answer is how much is coming, you calculate how much answer is coming. That is 20 point, how much you calculate? 20.9 joule. It will be 20.9 joule. This is the CV value. Calculate because question given at constant volume that are given. So CV is this much. If CV is this much, what is the value of CP? CP is equal to CV plus R. So CV is equal to 20.9 plus R is 8.314 joule. Answer is 29 point, how much? How much result? 29.21. 29.21 joule. This is the value of CP. So as for the question, CV was asked and CP was asked. Then what is gamma? Gamma means what is the atomicity of gas. So gamma is equal to Cp by Cv. Here Cp is how much? Cp is equal to 29.21 upon what is Cv value? Cv value is 20.9. 20.9. What is the answer? The result will be how much? 1 point. 1 is must. 1 point. If you derive, it will be 1 point. Approximately 1.4. 1.4 is coming means it is diatomic. Because 1.4 is diatomic gas. So this was the question, that what is the value of Cv, what is the value of Cp, what is the atomicity. Atomicity means gamma. We can know the atomicity of gas, whether monatomic, diatomic, from the gamma value. Gamma is Cp by Cv. Okay, so this is regarding the important concept of molar heat capacity, specific heat capacity, relation between Cp and Cv, and how we can know the atomicity of gas, whether monoatomic, diatomic, from the gamma value. This and the energy associated of the system or the any gaseous, we can say it is a gas. It depends upon three motion: translation motion, vibrational motion, and rotational motion. So this is regarding the concept of heat capacity. Okay, you practice, any doubt you can ask me. Okay, thank you.